Elixir Guides, Doctests, Patterns, and Width. In this chapter, we will implement the code that parses the commands we described in the first chapter. After the parsing is done, we will update our server to dispatch the parse commands to the KV application we built previously. Doctests. On the language homepage, we mentioned that Elixir makes documentation a first-class citizen in the language. We have explored this concept many times throughout this guide, be it via mix help or by typing h, enum, or another module in an IEX console. In this section, we will implement the parsing functionality, document it, and make sure our documentation is up to date with doctests. This helps us provide documentation with accurate code samples. Let's create our command parser at lib kvserver command.ex and start with the doctest. So def module kvserver.command, then we have an @doc, parses the given line into a command, examples. Doctests are specified by an indentation of 4 spaces, followed by the IEX prompt in the documentation string. If a command spans multiple lines, you can use ... as in IEX. The expected result should show at the next line after IEX or ... lines, and is terminated either by a new line or a new IEX prefix. Also note that we started the documentation string using @doc, capital S sigil, and 3 quotes. The capital S sigil prevents the carriage return characters from being converted to a carriage return and line feed until they are evaluated in the test. To run our doctests, we'll create a file at test kvserver command test.exs and call doctest kvserver.command in the test case. So def module kvserver command test, use xunit case, async true, doctest kvserver.command. In the test suite, the doctest should fail. Not implemented. Excellent. Now let's make the doctest pass. Let's implement the parse1 function. Our implementation splits the line on whitespace and then matches the command against a list. Using string split1 means our commands will be whitespace insensitive. Leading and trailing whitespace won't matter, nor will consecutive spaces between words. Let's add some new doctests to test this behavior along with other commands. With doctests at hand, it is your turn to make tests pass. Once you're ready, you can compare your work with our solution below. Notice how we were able to elegantly parse the commands without adding a bunch of if-else clauses that check the command name and the number of arguments. Finally, you may have observed that each doctest corresponds to a different test in our suite, which now reports a total of 7 doctests. That is because xunit considers the following to define 2 different doctests. Without new lines as seen below, xunit compiles it into a single doctest. As the name says, doctest is documentation first and a test later. Their goal is not to replace tests, but to provide up-to-date documentation. Width. As we are now able to parse commands, we can finally start implementing the logic that runs the commands. Let's add a stub definition for this function for now. So def module kv server command, and we have a run. Before we implement the function, let's change our server to start using our new parse1 and run1 functions. Remember, our readline1 function was also crashing when the client closed the socket, so let's take the opportunity to fix it too. Open up lib kvserver.ex and replace the existing server definition by the following. If we start our server, we can now send commands to it. For now, we will get two different responses: OK when the command is known, and unknown command otherwise. This means our implementation is going in the correct direction, but it doesn't look very elegant, does it? The previous implementation used pipelines, which made the logic straightforward to follow. However, now that we need to handle different error codes along the way, our server logic is nested inside many case calls. Thankfully, Elixir 1.2 introduced the with construct, which allows you to simplified code like the above, replacing nested case calls with a chain of matching clauses. Let's rewrite the serve1 function to use with. Yeah, that's much cleaner. Much better. With will retrieve the value returned from the right side of the arrow, of the left arrow, and match it against the pattern on the left side. If the value matches the pattern, with moves on to the next expression. In case there is no match, the non-matching value is returned. In other words, we converted each expression given to case 2 as a step in with. As soon as any of the steps return something that does not match OKX, with aborts and returns the non-matching value. Running commands. The last step to implement kvserver command.run1 is to implement that, to run the parse commands against the kv application. Its implementation is shown below. Every function clause dispatches the appropriate command to the kv registry server that we registered during the kv application startup. Since our kv server depends on the kv application, it's completely fine to depend on the services it provides. You might have noticed that we have a function head, def run command, without a body. In the modules and functions chapter, we learned that a bodiless function can be used to declare default arguments for a multi-clause function. Here's another use case where we use a function without a body to document what the arguments are. Note that we have also defined a private function named lookup2 to help with common functionality of looking up a bucket and returning its PID if it exists, and the tuple error not found otherwise. By the way, since we are now returning error not found, we can amend the writeLine2 function in kvserver to print such error as well. Our server functionality is almost complete. Only tests are missing. This time, we have left tests for last because there are some important considerations to be made. kvserver command run1's implementation is sending commands directly to the server named KV registry, which is registered by the KV application. This means this server is global, and if we have two tests sending messages to it at the same time, our tests will conflict with each other and likely fail. We need to decide between having unit tests that are isolated and can run asynchronously, or writing integration tests that work on top of the global state, but exercise our application's full stack as it is meant to be exercised in production. So far, we've only written unit tests, typically testing a single module directly. However, in order to make KV server command run 1 testable as a unit, we would need to change its implementation to not send commands directly to the KV registry process, but instead pass a server as an argument. For example, we would need to change the change runs signature to def command PID, and then change all clauses accordingly. Feel free to go ahead and do the changes above and write some unit tests. The idea is that your test will start an instance of the KV registry and pass it as an argument to run to, instead of relying on the global KV registry. This has the advantage of keeping our tests asynchronous, as there is no shared state. But let's also try something different. Let's write integration tests that rely on the global server names to exercise the whole stack from the TCP server to the bucket. Our integration tests will rely on global state and must be synchronous. With integration tests, we get coverage on how the components in our application work together at the cost of test performance. They are typically used to test the main flows in your application. For example, we should avoid using integration tests to test an edge case in our command parsing implementation. Our integration test will use a TCP client that sends commands to our server and assert we are getting the desired responses. Let's implement the integration test in test kv server test.exs as shown below. So diff module kv server test, use xunit case. We don't have the async true. Then our setup is we stop the application, and then we start it. And then this other setup that has options, connect to the socket, and then we're just passing in the socket. Our integration tests check all server interactions, including unknown commands and not found errors. It's worth noting that, as with the ETS tables and linked processes, there is no need to close the socket. Once the test process exits, the socket is automatically closed. This time, since our test relies on global data, we have not given the async true to use xunit case. Furthermore, in order to guarantee our test is always in a clean state, we stop and start the KV application before each test. In fact, stopping the KV application even prints a warning on the terminal. To avoid printing log messages during tests, xunit provides a neat feature called capture log. By setting @tag capture log before each test, or @module tag capture log for the whole test suite, xunit will automatically capture anything that is logged while the test runs. In case our test fails, the captured logs will be printed alongside the xunit report. Between use xunit case and setup, add the following call: module tag capture log. In case the test crashes, you will see a report as follows. Oops, stack trace. The following output was logged. With this simple integration test, we start to see why integration tests may be slow. Not only this test This test cannot run asynchronous. It also requires the expensive setup of stopping and starting the KV application. In fact, your test suite may even fail and run into timeouts. If that's the case, you can tweak the gen TCP receive v socket 1 call to pass a third argument, which is the timeout in milliseconds. In the next chapter, we will learn about application configuration, which we could use to make the timeout configurable if desired. At the end of the day, it is up to you and your team to figure out the best testing strategy for your applications. You need to balance code quality, confidence, and test suite runtime. For example, we may start with testing the server only with integration tests, but if the server continues to grow in future releases, or it becomes a part of the application with frequent bugs, it is important to consider breaking it apart and writing more intensive unit tests that don't have the weight of an integration test. Let's move to the last chapter. We will finally make our system distributed by adding a bucket routing mechanism. We will also learn about application configuration. All right, that's it for today. Cheers.